team, welcome to the numbers game. I'm Coach T, and in this tutorial we'll be doing a proof by induction. Let's get started. Our example says use induction to prove that for every integer n greater than or equal to 5, 2 raised to n is greater than n squared plus 5. We'll start with our basic step. Typically for our basic step, we would say n equals 1, but our problem says n is greater than or equal to 5. So for us, we'll say for n equals 5, we have 2 raised to n, which equals 2 raised to 5. Now 2 raised to 5 equals 32, which is greater than 30, which equals 5 squared plus 5, which is the right side of our equivalency sign in our example, n squared plus 5. So in our basic step, we see that 2 raised to n is greater than n squared plus 5. Now for our induction step. So let's assume that 2 raised to n is greater than n squared plus 5. We need to prove that 2 raised to n plus 1 is greater than n plus 1 squared plus 5. This is what our induction step entails. Since we're assuming that 2 raised to n is greater than n squared plus 5, we have 2 raised to n plus 1, which equals 2 times 2 raised to n. And note that this is greater than 2 times n squared plus 5. So I'm going to pause and take a moment to explain what I'm about to do. Again, we're trying to prove that 2 raised to n plus 1 is greater than n plus 1 squared plus 5. So we're going to start our induction with 2 raised to n plus 1, and we're going to work our way down to n plus 1 squared plus 5. Now note that, and this stuff in purple is not a part of our formal proof, n plus 1 squared equals n squared plus 2n plus 1. And n plus 1 squared plus 5, we can add the plus 5 back in there, equals n squared plus 2n plus 1 plus 5. So if we can prove that 2 raised to n plus 1 is greater than n squared plus 2n plus 1 plus 5, we can conclude that 2 raised to n plus 1 is greater than n plus 1 squared plus 5. Proving a claim with induction is not easy because it takes a certain level of foresight for sure, but that's what we're going to try to do here. All right, so back to our proof. We've got 2 times 2 raised to n is greater than 2 times n squared plus 5, and this is greater than n squared plus n squared plus 5. And this is obviously true because if we distribute that 2, we get 2n squared plus 10. Or in other words, n squared plus 10, which is obviously greater than n squared plus 5. All right, so n squared plus 5 is greater than or equal to n squared plus 5n plus 5. Now this is greater than or equal to n squared plus 3n plus 2n plus 5. I hope you guys can see we're starting to get closer to this here, our goal. So from here we see that n squared plus 3n plus 2n plus 5 is greater than or equal to n squared plus 2n plus 1 plus 5. And this is equal to n plus 1 squared plus 5. We made it. So therefore, 2 raised to n plus 1 is greater than n plus 1 squared plus 5. So by induction, we've proved that 2 raised to n is greater than n squared plus 5. And there you have it. We've proved our claim using induction. If this video was helpful for you, give it a thumbs up, like the video, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.